Hello everyone, I am Dr. Nicolas Nassar, an instructor at the Faculty of Dental Medicine, St. Joseph University of Beirut. I am happy to share with you, on behalf of my co-authors, our study entitled En-Masse Maxillary Dentition Distalization with Clear Aligners using Infrazygomatic Mini Implants, a finite element study. Clear aligners have transformed orthodontics, offering an aesthetic alternative to fixed braces, especially for adults. Initially used for simple cases, advancements now allow their application in complex malocclusions. Additional anchorage methods, such as mini implants, have facilitated the management of mild to severe malocclusions without having to extract premolars. Mini implant in the infrazygomatic crest provides stable skeletal anchorage, enabling en-masse maxillary dentition distalization. Despite their success with braces, limited research exists on using infrazygomatic mini implants with clear aligners. Our study aims to evaluate the biomechanical effects of infrazygomatic mini implants on en-masse maxillary dentition distalization using clear aligners, employing 3D finite element analysis to predict treatment outcomes. Three-dimensional finite element models of the maxilla, maxillary teeth, periodontal ligaments, alveolar bone, and clear aligners were created using SolidWorks 2019 and analyzed in ANSYS Workbench version 15. Three models were created with different lever arm heights for force application. Model 1, 0 mm at the cemento-enamel junction level. Model 2, 4 mm above the cemento-enamel junction, and Model 3, 8 mm above the cemento-enamel junction. The mini implants were placed between the first and second molars, 15 mm above the occlusal plane, and at a 60-degree angle for optimal bone engagement. A distalizing force of 2.8 Newton was applied to induce controlled maxillary dentition movement. Tooth movement was assessed at key anatomical points such as the incisal edges of incisors, cusp tips of canines, central grooves of premolars, and mesiobuccal cusp tips of molars. Our study results show that infrazygomatic mini implants with force application arm length of 0, 4, and 8 mm supported maxillary dentition distalization with clear aligners. Displacement tendencies for the anterior teeth exhibited similarities across all force application arm length in all three dimensions, with the exception of the canine, which displayed a distinct vertical displacement in the model with an 8 mm arm length. Among all maxillary teeth, only the canine exhibited distalization of both the crown and root. The crown of all molars and premolars underwent contraction during distalization, accompanied by mesial root movement. The maximum magnitude of distalization was observed with the posterior teeth at the 0 mm force application arm length, characterized by minimal tipping and fewer vertical movements compared to the 4 and 8 mm arm length. Let's start with a vertical displacement. The incisors demonstrated intrusion while all posterior teeth were extruded, excluding the second molar at the 0 and 4 mm arm length, where intrusion occurred. The canine exhibited intrusion at the 0 and 4 mm arm length and extrusion at the 8 mm arm length. Let's move to the horizontal displacement. The largest occlusal displacement was achieved at the 8 mm arm length, leading to expectations of a concurrent increase in apical displacement at this length, which was confirmed by the numerical data. As for the sagittal displacement, only the canine displayed distalization involving both crown and root. The highest occlusal distalization for the posterior teeth also occurred at the 0 mm arm length. Despite finite element limitations, these findings aid treatment planning with clear aligners and infrazygomatic mini implants. Clinical trials are needed to validate real-world applicability, and future studies should assess long-term displacement. Thank you for listening. For the full article, kindly refer to the Korean Journal of Orthodontics, March, Volume 55, Number 2.